Okay, so today I'm talking about the converter to FBX, or sorry, from FBX to my own format. The reason that it's very useful to do this is because I can convert it into a runtime format, and that's really easy to open inside of a game, and it does not need any kind of extraction while the game is actually running. In other words, as long as I know where the offsets for the data are, like the UV coordinates, the vertex, and the indices, I can quickly get the information right out of the file. So as a result, there's a separate tool that I wrote in order to facilitate this. And the idea is that this is much faster. And the way I set it up is actually it's two tools in one tool. So there is the converter and then there is the packer. And what the two do is basically that the converter converts each separate element into its own file with its own header, and the packer will pack them together with an overall header. And as a result, I can get, information out of it, like textures and vertices and whatever I want based on the overall header. And the way that it works is that basically once it converts everything, it's in separate files, and once it's done, it runs a tool that packs it all together and then stamps a header on top that gives me all the offsets for all the different files, or the different data, so that I can quickly say like texture 1 to model 1, texture 2 to model 1, whatever I want. So the basic idea is that the basic idea here is I have a debug folder that everything compiles to. A little note about the texture is that the texture is actually converted to a runtime format as well, using the ilut or devil library. There seems to be a bunch of names for the same thing. And so in case you need to run this, you need to plop the DLLs into the same directory as the exe itself. The way I execute the exe is I just shift and right click and I open command line, which gives me the current folder. So I can start typing in the commands for my converter. So the idea is that you just type in FBX converter and you specify the file. So I'm going to convert space forget.fbx, and then I say, and the output file, which is the file names for the output, which would be something like forget. And the idea is that what it does is it takes that R name and it applies to everything so that it can track down the files and then pack them all together in one. So if I hit enter, it runs through, it's done converting, it's actually pretty quick. And so there's a whole bunch of output in here that basically specifies like what it's doing. So it found a model, space forget, vertice count, poly count, UV normals, everything, and then it goes through and finds the textures as well. And then it runs the separate tool inside the same command line, and it basically says starts processing the output files. And the output files look like something like this. Where are they? Where I have forget mod texture 0 and forget mod vertice 0, which is basically means that I found a texture at 0 for a model, and I found a vertex information like UVs and things like that, normals, all that stuff, and it packs it into a separate file. And what the tool does that comes in and kind of cleans everything up into one file is that it just takes them, packs them, stamps a header, and then outputs forget.sgf, which is the file that we're going to use to load stuff in. So to kind of give you some more information about how this works is that it triangulates the mesh so that it doesn't have to tell the difference between whether it's what kind of mesh it is. It's just triangles, as long as the converter outputs triangles. And So here you can see system starts calling out the second tool that packs everything together. And what it does is it looks for any files that match up to the output name that you specified and starts looking for .mod and then .text and starts parsing those into one file. And it also stores an array of all the offsets that are necessary. So in order to load this into the engine, I'm going to actually, I'll have the, it looks like I have the wrong one open. Sorry about that, I have the wrong one open. Model importer. Okay, so in order to load them in, it's very simple. You actually just say, there's a model loader class, which is basically a static class, or has static functions in it that basically do certain operations. So, for instance, I have a load model which returns a model, like an imported model. And all you have to do is specify frigate.sgf. And then you have to also extract the texture separately. So you say model texture frigate.sgf, and then you specify the identifier, and you can also specify which model you want. So in case there's two separate meshes inside of one model, you can also say model 0, model 1. The idea is that there's a certain decoupling, so I can actually apply the same model or the same texture to multiple models, even if they're not related to one another. Or I can swap models and things like that. So so what happens is you go and you plop the SGF file in. So I'm gonna go into debug, copy frigate, and then say paste, replace, and it's in there right now. So you have to do it in the same exe location wherever you have your like the game runtime exe. Because I'm in Visual Studio, it tends to see the code directory as like the directory it starts reading from. So I'm going to put it in there. And so I've already set this code up, and what happens here is it loads in the frigate SGF, and then it extracts the first texture it can find from the frigate. And so before I like open up the whole thing, there's a whole bunch of like different models in there that I've already loaded in. I'm just trying to show you like how to get it in. It's very simple. You just say frigate.sgf, and then so in order to do all this stuff, there's actually kind of like an abstraction, like a double abstraction, where you have the load model and load texture, but you also have I have an SGF unpacker that does it's a class that does a whole bunch of different things, like reads headers, reads data, like just kind of gives me an interface to my format. So in case anything changes, I can just change the SDF unpacker and the interface stays the same. So if we run all of this, and there's missiles, there's warbear, and then there's radio tower in here. So if I run this, I get so that's the frigate, and that we talked about, or I talked about. And then there's a couple more models like the missile, and then the radio tower in the back, and then there's the different scalings for the warbear. So what I did to demonstrate a little bit is kind of like a different texture system. So this is actually just I took a different texture and applied it onto a model that I imported, kind of like a dynamic way where in the end they're all independent, even when you load in your stuff, you load it in as one mesh or one texture, but you can extract those textures and use them somewhere else if you really need to. And so this is just another shader that kind of shows that the normals have been loaded in correctly. And just rotations and scaling and rotation as well for warbear. like so. And so that's pretty much what I have right now, and it loads in. It's very easy. It's very simple. You just need to specify. There's a bunch of helper functions like the model loader, which just does all the parsing and loads the model and everything that you need. And you can also access the actual SF unpacker static class that just gives you like the headers and stuff like that for it. So that is my importer exporter.